All right, today for algebra, we are doing section 4.5, disjunctions. Yesterday we talked about conjunctions. Today we're talking about disjunctions. All right, so our objectives today are we want to be able to define, okay, a disjunction, and we want to be able to solve and graph disjunctions. So first, let's look at the definition. A disjunction is a compound sentence that's connected by or. Okay, that's it. It's connected by or, and the symbol for that is this V. Okay, for our union, if you remember back to set notation when we started, an or statement was a U. It's very similar, we're just using a V, kind of looks like a U. Much like in the conjunctions, we had the intersection, now we're looking at the union. So, those are our two things. A disjunction has an or in the middle of the compound sentence. So, for a disjunction to be true, so if we want to know if it's true, only one statement must be true. So the solution is going to consist of any value that's part of the solution set of either inequality. So before they had to overlap in a conjunction. In order to have a solution, both statements had to be true and the solution had to overlap. That's not the case for a disjunction. Either statement can be true. Okay, only one has to be true. So to solve it, we're going to have some of the similar steps. We're going to graph the two simple inequalities first, because remember it's compound, so we're graphing two simple ones. We're going to find the union. So that means we're going to include any value on one or both graphs. Doesn't matter. We're going to include all of them. And then we're going to graph the union. So we graph the two inequalities, we find the union, and then we graph the union. And this is going to make more sense when we actually do it. So let's go on down to our examples. Let me move it on up so we can get them all in there. Perfect. Okay, so we're going to graph the solution set. An example 1 here. So we have x is less than -4 or x is greater than -1. So again, it's an or statement, so it's a disjunction. All right, so I graphed the first one. It's less than -4, so it's an open circle going to the left. The one on the right is an open circle. It's going to the right. All right, there's no overlap. None. But this is a disjunction. So this was step 1, right? We graphed the two simple inequalities. There's an area of no overlap. So both of these are the solution. This is our actual solution. We graph it on the number line. That is our solution. There's no other simpler way to write it. That's just it. Okay, let's look at B. B looks a little bit differently. So we have x is less than 4, or, okay, this is that disjunction symbol here. It can replace the word or, but that's what it means. X is less than or equal to 2. So step 1, we're going to graph each of these. So x is less than 4, so I've got an open circle and my arrow going to the left, or x is less than or equal to 2, so closed circle, arrow going to the left. Okay, in this case, again, we're looking for any number at all that's included. So the biggest number that's included is this 4. And then our answers, all of our answers go to the left. So we're going to say the solution is less than 4. That's our final solution. And that's what we write here. X is less than 4. That's our final solution, okay, for the union, because it includes, so the x is less than 4 includes all the solutions for each inequality, because we have to include them all. All right, so step 3, or example 3, sorry, says solve and graph the solution set. All right, this one, we are doing multiple steps. It's not just graphing the solution set. I have to solve it and then graph. All right, so part of A is done for you. It's just like balancing that equation. We had 3x plus 4 is greater than 16. So we subtracted 4 from both sides. Now we have 3x is greater than 12. We divided by 3 on both sides. And now I have x is greater than 4. All right, which I also graphed. So we've got greater than, open circle, and x is greater than, so it goes to the right. Let's do the next one. Negative 5x is less than or equal to 20. So we're going to divide by negative 5, which I'm going to go ahead and flip my sign then right away because I divide by negative. Otherwise, I forget a lot. So I divide both sides by that. Our negative 5's canceled, and I have x is greater than or equal to negative 4. All right, so I'm at negative 4. It's greater than or equal to. So it's going to be a closed circle. And it's going to go this way. Okay, so my solution, my overall solution has to include both of those. Right? So my solution to this one would be on the number line, negative 4. Okay, and it would go this way. So our final solution is x is greater than or equal to negative 4. Because that includes the x is greater than 4 as well. All right, so it's like we're graphing, it looks like we're graphing 3 times, but the simple ones, the orange and the blue one, were the ones from up here, right, where we first had them. And then the one on the number line is our final answer. It's our solution. It includes everything. Okay. Also notice, again, we have the disjunction symbol there, and we have that disjunction symbol in B as well. Okay, so it's an or. We know it's an or statement. All right, so let's do B together, and then we're done today. Like that's it. Our worksheet, our notes today are just the one side on the front. Then you can go ahead and spend your time working on your homework. Okay, so if we look at this one, the first inequality we have is 3x minus 6 is less than or equal to 12. First step here is, good, add 6 to both sides. Then we have 3x is less than or equal to 12 plus 6 is 18. Okay, what's our next step? Very nice, divide by 3. So x is less than or equal to 6. Okay, so I've got a positive 6. It's less than or equal to, so it's going to be an open or a closed circle. And it's going to the left for that one. Probably should have kept it all blue. Let's go to the next one. All right, we have 5x is greater than negative 25. So let's divide by 5. Our 5's cancel. X is greater than negative 5. Because negative 25 divided by 5 is negative 5. Okay, so negative 5, it's going to be an open circle at negative 5. And x is greater than So what is the answer for this one, do you think? Because it's really, I mean, to graph it, it includes all these numbers, right? Because there's overlap anywhere from 6, right? It's less than or equal to 6, so all these numbers. And then we've got negative 5, and it's greater than all those numbers. So our answer is kind of the whole number line, right? Absolutely. This is the whole number line. There's no points on it, and we would say it's all real numbers for the solution. Okay, so you can use that symbol, or you can write all real numbers. I would take either of those. Okay, but every single number on the number line is included in the solution set. One of those is always going to be correct. All right, that's it today for disjunctions. So hopefully with having conjunctions yesterday, which were the and statement, disjunctions today, we've got them all covered. Okay, so we will spend time tomorrow working back and forth between conjunctions and disjunctions. Okay, so you get practice using the symbols and paying attention to the symbols, but we'll have another review day, or we'll have another day tomorrow to work on both of these at the same time. So good luck on your homework, and I'll see you tomorrow.